So the goal of Project Blocks is to develop an open hardware platform that provides designers, developers, and researchers everything they need to create tangible programming experiences for kids.
One of the big things about teaching kids how to program is that they can express ideas that they wouldn't be able to express otherwise. Young kids, they learn by being social, by being collaborative, by playing with things, by exploring with their hands, taking what's natural to them, and then adding a new skill, such as computing and programming. I think we have the best of both worlds.
I think if one moves away from the screen and keyboard to coding, it's far easier for young people to work collaboratively, and working collaboratively to solve problems is what happens out in the real world.
There's a long history of tangibles for programming. It starts in the 70s with Seymour Papert at MIT, and then there are many others, for example, Turn, and then Topobo and tangible programming bricks.
So one of the cool things about tangible programming is accessibility. You've got the little kids who can't, read and write yet, but then you've also got students who have dyslexia who can access coding without having 1,000 syntax errors.
For the most part, the things that we produce in our group are platforms so that developers can really innovate on the content and the applications.
Project Blocks is a research project, and our goal is to create an open hardware platform in which developers, makers, and designers can create hands-on programming experiences for kids. As a first step, we've created a system for tangible programming. And the system consists of three main components: a brainboard, baseboards, and pucks. The baseboard works by placing a puck onto it, and pucks can be programmed with different instructions like turn on or off, move in a direction, or increase amount. The board then simply reads that puck's instruction. The brainboard provides power and connectivity, and when you connect baseboards to it, it can read the instructions and send them to connected objects like a toy or a tablet. The boards can be rearranged in different ways and wrapped in different forms and materials to create all sorts of physical coding experiences, like a music maker, where you use physical code to compose music and send it to a wireless speaker. Or a sensor lab, where you use physical code to experiment with sensors around you, like detecting a drop in temperature and then switch on a light. Or a coding kit, where you use physical code to control toys, like getting a robot to draw a shape on a piece of paper.
You're now enabling every maker out there to come up with their solution to what could be tangible computing. So suddenly, as a teacher, I'm excited because there's a whole world who's going to be developing tools that I could potentially use in my classroom.
The ultimate aim of Project Blocks is to give all the work we've done back to the education, research and development community for free to accelerate the field of physical programming for kids.